Hi, welcome everyone. Good morning for another weekend, 15th session today and 16th session tomorrow. We have very good topics. We are entering into a new level, new stage. I encourage everyone to get up. So quickly, if we see, we have friends, Harish. Harish, welcome. How are you today? You want to greet our friends? Harish is no problem. Mute. Surya Sairam, welcome. You want to greet our friends?
Yeah,
Hi
good morning,
Srini.
guys. Hope you guys are having all fun.
Excellent.
Hi Srini. I'm doing good. Good morning to all.
Excellent. Welcome. So we have Leela and Raja. Hey, how are you guys? Welcome. You want to greet your friends?
Hi Shini, good morning to all.
Hi Srini, good morning everyone.
Welcome. So Harish is dialing in, I think. Narendra from India. Hey, Narendra, how are you? You want to greet your friends?
Hi, Frini. I'm good. Hello, everyone. Good morning.
Excellent. Welcome. Fully. Others are joining. So let's continue. We have a very good session, going to have a very good session today with Harun. Here we have Siva and Kiran. Kiran, how are you guys today? You want to greet our friends? Siva just joined. Kiran is on mute. Kiran, welcome.
Hi Srini, hi everyone.
Excellent. Great to hear your voice, Kiran. Welcome. So we have Hema joining. We have Harish hasn't connected the voice yet. Hema, welcome. How are you today? And do you like to greet our friends?
Hi all, good morning.
Welcome. So Harish is joining. Okay, welcome. I think we have a good quorum. Let me. Okay, I'll be handing over this to Harun in another 5 minutes. So just quickly, this weekend today Harun is going to lead the session, and after that he will hand over to Hema for a demo, brief demo. This is to Hema's demo is to warm up for what is coming up, to make sure everyone to involve. Machine learning, artificial intelligence is, once again, I want to tell, it's very hot in the market, and it's only the beginning. And again, it is not something like other skills, in 1 or 2 years, it's a subset. No, it's going to explode because so many fields, every government, every company, every non-profitable organization, every health institute, health organization, every defense, economics, even political. You have seen Cambridge Analytica issue with Facebook became a big news. So all the social and food industry, products, customer industry, genomics, brain related, and whatnot, astronomy, name every field, this is going to touch. Already people are implementing. So as once again, I want to encourage you to step back and see it totally differently. It is a new discipline, as I mentioned earlier. It is not just a skill you are learning. If you have this skill, you may be meeting people from Stanford, people from Harvard, people from MIT, and you'll be talking to them. They may be your colleagues. It may be PhD from Stanford or masters from MIT. So you can go to any extent. So these are so powerful, those so powerful. Yet it is not very, very complicated. It is not easy, definitely. If it is easy, people will just jump. So that is where we want to make comfortable to you. So for that, we are going systematically. In few areas, you get overwhelmed. That is very, very natural. That is very, very natural. But that is where I want you to stop a little bit and think in the class, think when you go home, what is happening, what we're doing, a few points here and there. Oh, we're talking about indexes, we're talking about some vector assemblers. If you see them isolatedly, in isolation, there will be little confusion. So that is where I want you to see, think critically, hey, what we are trying to do. What we are trying to do. Like that, you need to critically think and also go step by step. At this stage, what we are doing? Are we dealing with collecting the data? At this stage, are we trying to clean up the data? So at this stage, are we training the data? At this stage, are you testing the data? At this stage, are we doing hyperparameter tuning? So at what stage we are? I have a confusion. That's fine. You'll have confusion, but confusion is going to go away. At what stage I have this confusion? Do you have confusion in the hyperparameters tuning? Do you have confusion in the training the data? So you need to be very clear on that. So anyway, so I encourage you, we are entering into a next level of training. Till now, we have a very good foundation. So in the next level of the training, on the big data engineering side, we are entering into streaming. We are entering into real-time data flows. Till now, Arun has helped us to do the batch RDDs, Hive, and whatnot, different format, JSON format, Parquet format. Any big data now you can able to handle on the cluster. The good news is you should focus more on programming and algorithms, not on infrastructure. So infrastructures are taken care by cloud, administrators, where they run it, what loads they run. So those are things nowadays very much automated. Okay. So give me a second, somebody shouting us. Okay, I will connect with you. Okay. So, I want you to encourage you focus on doing Scala code, step by step, small codes. Don't write big things, small functions. You're getting comfortable. So Harun is going to focus on this streaming, a real-time data flow. Real-time data flows are very, very important. Especially, this is where you need actually big data. A lot of people think a batch they can handle without even big data, even though it's very much essential. Because some people think they don't have data, much data. They might have 10 gig data. They will try to handle without batch, just to write some Python code or some Java code. They think that we can handle this data. But what if your data is flowing? How you handle it? You cannot write simple Java programs or simple Python programs, because that flow of data, the streaming data. I'm not talking about web services. Those are real-time transactions. These are not real-time transactions. These real-time data flow from systems to system. How you handle them? As the data flowing, You need high availability. You need what you call scalability. Even though scalability is not a big issue, you need high availability. If any messages drops, how you handle it. So if you write a general programs, you have to handle all those things in your code. So that is where these big data technologies have done heavy lifting. Why they are doing heavy lifting? Try to understand the spirit of the technology. The spirit of the technology is not how much you lift it. No, the spirit of the technology is to solve the big problems. So that is where the technology matures. When there was no big technology, Smalltalk was the object-oriented program. A lot of people worked on mainframes. Just to do small things, they have to struggle. Then we got a client server. It helped us a lot. It helped us a lot. We have a client server applications. Then we got a internet applications. Even PeopleSoft is a PeopleSoft internet architecture from 2000 onwards. Now we have a distributed databases. So much automation has been happened. It's all good, but for companies to steer a direction, to strategically move, to lead things, to innovate, they need analytical applications. The OLTP applications only capture the business process, automate the business process. So business is very efficient to address the known thing. How about unknown things? To address unknown things, to take new steps, new strides, new strategies. Businesses needs insight into the systems. That's where business intelligence is needed. The challenge is not just gaining insight into your data. You need to connect with social media systems, what people are talking, how the trends are moving. And you need to collect with so much weather data, government data, so many things, what is going on in the world. So a lot of collection of data exists, research data. So all these things has to be handled. So that is where, thanks to the open source big data technologies, which are available only to few people earlier, which used to cost millions of dollars, which is cost no fraction of dollars. So those technologies are available to us. So huge computing, improved algorithms, and data, all these things with a lot of good technologies, heavy lifting, and you just have to focus on very high level things, solving business problems. That is where you are adding the value. So these are powerful, powerful, powerful tools. You'll be surprised even after 10 years. You'll be surprised. So even after 10 to 50 years, these tools still exist because these are not few technologies. These are, as I told you, these are disciplines. Actually, these techniques exist 60 years back. I don't know if somebody will be surprised. These neural networks, these are there from 60s, almost 60 years back. Only thing is, because of computing, they are more widely used. So we are entering into a new stage. Now today, Hema is going to demo a multi-class classification. Till now, you are doing a binary classification. In binary classification, you have yes or no, yes or no. In multi-classification, you may have different categories, recognizing the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 9, rather 10 categories if you count 0. So these are 10 categories. How you, if you are getting new transactions, how you put into these buckets? You need to understand. This is not clustering. Please note, in clustering, it is a different. You cluster just to random groups, identifying patterns. But this is a dividing, how you divide your transactions into different categories. So she's going to demo. So Hema is going to give you the warm-up so that you guys are getting ready. So get ready. Every week, someone is going to demo. And tomorrow I'm going to discuss a concept called random forests. Random forests are nothing but decision trees. See, decision trees are simple. You ultimately, there is a logic, ultimately you go to a decision, yes or no, or multi-classification. Let's focus on binary, yes or no. If you have another tree, yes or no, yes or no. Another tree, yes or no, yes or no. So instead of one tree, you take the data, randomly divide the data into subsets, build multiple trees. Each subset may have its own tree, decision tree, randomly. Then you get the output. Out of all the output, you'll be taking the majority decision. I'll talk very detailedly tomorrow. So in everything appear little bit overwhelming to you, but if you go back into the basics, you see classification, you are just taking a decision yes or no. It is a binary classification. So here there are only two things. In every data, you need to check, hey, where is my label? Where are my features? Is it hard to ask you? Is it hard to ask you, Sairam? I give you so much data, Sairam. I just ask you, hey, where is the label? What are the features? Is that correct, Sairam? Fundamental.
Yeah.
Fundamental. Hey, I give you a data. Hey, this is my feature. This is my label. First, that is where we start, right? Then everything, see, check logically. You are doing indexing. Why you are doing it? How you handle the categorical variables. Your algorithms doesn't handle. I encourage you, don't do anything. Just go and give the table to the algorithm and see. You make the errors first. Don't even remember anything. You don't even act like intelligent. You just, say today Hema is going to show you in one file, in one line, a libsvm format. You will get a data frame with label and features. How powerful it is. So much data, image data, and image data in the form of libsvm string data. She's going to read and get in one line. Just read libsvm. That's it. She got labels and features. Okay, you construct a new decision tree algorithm and try to fit on it. It will throw you errors. It will say it has strings, it has category variables. Oh, okay. I'm getting errors, so I need to handle the category variables. Oh, let me do it. Let me, convert this, what you call this, features. I already have a features, but there may be some categories. So let me index it. Sometimes if you have numbers, strings are not there, your numbers are there, still you index it so that you increase the efficiency of it. Then you run it. Like the details are there, I don't want to steal the show today. You're going to have some more work. Thanks to Harun and Hema for stepping today. So I'm going to, I want to encourage you. This is what, think in that line. And moreover, see, we cover few things. We are not going to leave it. We are going to do some repetition. Repetition in the sense, iteration. It is not a repetition. Repetition is different. Iteration is different. Iteration means you do something. Even today, in every project or every startup, you start a company, you need to do iterative. So, hey, you studied relation tree. So, iteratively, you study it now. Tomorrow, Hema is going to demo. So, another iteration. Next, in 2 weeks, Sairam is going to plan customer churn. He agreed to give a demo in 2 weeks. So that is another iteration to you. Then we divided teams into different. Hari, welcome from India. So Harish, other people are focusing on customer recommendations. Hari team is going to focus on clustering. So I'll give 2-3 weeks advance notice for you so that you prepare and get ready. So they give the iteration for you. So that is how through collaboration you all become stronger. Excellent, guys. Any question? How does this sound, Kiran? Harish? Hari? How does this sound?
Sounds very good.
Excellent. So let me hand over to Harun. Harun, I'm giving you the host access so that you can take care. Then after you take a break, then give it to Hema. Yeah. Harun, welcome. Take over. You're on mute. I gave you the host access and I'm stopping sharing.
Yeah, sure, Srini. Thank you. Okay. Hello, guys. Welcome all for another session on the Spark ML and AI. So today, we will continue from our last session, Spark Streaming. We will not do much on the Spark Streaming because I want to introduce the visual layer, the presentation layer, where we want to store the data. Till now we were getting the data and displaying. So we want to introduce the visualization layer that we were discussing. So today we'll start with Elasticsearch. Just I'll give you introduction how you put the data, how you visualize the data. Why I'm doing this is, let me share my screen. Okay, so you guys can see my screen and hear me, all right?
Yeah, Harun.
Okay. Okay. So, so we will get started. This is our, the basic picture where this all started. So we have explored the batch. We've seen how Spark Streaming is, but to work more with the Spark Streaming, you always need the connectors. You always need the data flowing. You need a source and you need a data store to store and visualize, right? So for the batch, we worked with various files, file data, and then for streaming, we looked at the Netcat. So manually putting in data on a port and reading the socket, reading the data from socket. So to put more data into it, we add Kafka and Twitter data onto this. So I will talk about Twitter next class, and then we'll slowly introduce Kafka also into the stream to ingest the data. So today we will start on the serving layer. We will discuss Cassandra and Elasticsearch going forward. So today we will start with introduction to Elastic and then see how we interact with Elastic and what is Elastic, why it is important for us. Okay, so there might be a lot of many other sources and the visualization layer, serving layer tools, and the ingestion layer tools. So we should get started connecting all of these together to form the data pipeline. Okay, so that's the idea. So we will start with Elastic, what it is, the architecture, and how we interact with Elastic data and all that. Then we will later connect the Elastic with Spark Streaming. Then we will try to write and get the data using Spark Streaming, either batch or streaming. So we will first start with the batch, reading and writing the data to Elastic. Then we will move on to streaming when we connect the sources like Kafka or Twitter. Then what we will do, instead of batch, since the data in the Twitter or Kafka will be continuously flowing, so instead of batch, then we will move on to streaming. Then we would connect the pipeline from the streaming data from Twitter or Kafka through Spark Streaming into one of the serving layers, Elastic and Cassandra. So that's how we are going to proceed going forward. So we'll slowly start adding the tools, adding the layers to our data pipeline. So hope all the team is comfortable with the batch layer and the file data reading and writing and integrating with Hive. We had here HDFS Hive, right? So we will move on to the next level. We'll start exploring some of the architecture tools. Okay.
Okay.
Yep. So, and streaming also, we will discuss some of the concepts like how do we do the transformations on a streaming data kind of a thing. So first I will explore a small data, how we do a transformation. What is a transform? Transform is just like a map function on the Spark Streaming. Okay. And then we will move on to the Elastic. All right, so I have created a new class in the same package, Spark Streaming Transform, and I have downloaded, I have imported the packages that are required for streaming here. Now we will create the same how we are doing from the socket text, but how do we transform on a streaming data, just like we do on the normal batch data RDD. So the same transformations we can do on the streaming as well. So what are the various transformations that we discussed? We can do map, filter, transform, join, all of those we can do on the stream, on the D stream, the discretized stream. Apart from that, as we mentioned, there is a concept called windowing. Okay, so let me get yeah. So so continuation to our discussion. So we also have something called windowing. Okay, so what the concept of windowing is, you have two parameters, window length and sliding interval. Okay, so what that means is that when the data is flowing as a stream, okay, you want to visualize the data at any particular point of time. Okay, so the good example would be, say, the stock market. Okay, so the stock market, as you keep watching, you see the trends, right? Now, what does the trend say? That when you look at the trend, you can watch the prices of a particular share going up or down in a particular interval of time. So you can watch the trend for past 30 minutes, for past 1 hour, okay, right? Or past 1 day, 1 week. Got that? Yeah. So you understand what I'm saying, right? So you want to watch the trend of, say, the stock market. Now, that is static. Now, for any stockbroker who's looking at the trends, he continuously wants to monitor the stock price on the go, like live. So how is it the trend? Is it growing or is it falling? When? How often do I want to check, right? Say I want to check every 1 minute. I want to check, Okay, so which means that you want to refresh the data, the dashboard every 1 minute, right? So every 1 minute you can do that. Now, how long the data I want to see? So do I want to see the last 1 hour data, 1 month data? So it doesn't make sense for me, right? Because I want to do it live. So it doesn't make sense for me to look at 1 month data right now for every 10 seconds, right? So let's say I want to see what's happening in the last half an hour, right? So last half an hour, what is happening? And I want to see every 10 minutes. You understand the concept?
Yeah. This is
Okay.
the live streaming. No?
Yeah, live streaming data. So that is exactly what the DStream has called window length and sliding interval. Okay. So sliding interval tells you the interval at which I want to check the window, which means say 10 seconds or 10 minutes. Okay. Or 10 minutes. I want to check the data for last 30 minutes. So every 10 minutes, I want to take the last 30 minutes, right? So say this is the data here, time 1, 2, 3, 4, 5. Okay. Forget about what this is. Time 1, I have particular data, which means that I got the prices for a stock. So because it's a DStream, if I get the stock market data, so I get the prices for all the products, all the shares, right? At time 2, which is after say the reading interval is say 5 minutes. So after 5 minutes, again I get the data at that point of time. What is the price, right? Now again after 10 seconds, I get another set of data with the prices. Now, if my sliding interval is say 10 minutes, so these are 10 minutes apart, these data batches of data in the stream, and I want to take last 30 minutes of data. So 30 minutes is, say I am here now at time 3. Okay, what is my last 30 minutes of data? 1, 2, 3. Every 10 minutes I'm getting, right? So this dotted line is all last 30 minutes of data, correct?
Correct.
Right. So what I get is a DStream of all these 3 packets of data joined together as a window data. So at this window, at time 3, I have the data from time 1 to time 3 all joined together. This is a window I have defined. So if I look at this window, I see only the data for last 30 minutes or 30 seconds, whatever. Let's talk about seconds. Okay. Let's say last 30 seconds, I see the data at this point of time. Okay. Now my sliding interval say is 10 seconds. Okay. Which means that after 10 seconds, I am here, right?
Right.
So if I am here at time 4, now what will be my window here? Last 30 seconds. Here I will get another window. Don't worry about this picture. It is not given continuous flow of data. It's just a sample. So at time 4, what is the window of data I get?
From time 2 to time 4.
Window time 4, right?
Yeah. So I get 2, 3, 4 because my window length is 30 seconds. My sliding interval is 10 seconds here. So I get 1, 2, 3. So the combination of these 3 data. So you have to also note that the data is repeating, right? So time 3, I get a snapshot here. And when I go here, it will also include time 3 with time 2, 2, 3, 4. And if I move to next interval, sliding interval, now I get 3, 4, 5. Now the data from time 2 is no longer here. It's fallen out of this window. Correct?
Correct.
So every 10 seconds, I'm getting the trend of my last 30 seconds.
Correct.
Correct? So that's how the windowing pattern works, the algorithm works. So you have 3 parameters here. You only see 2 here, right? There's one more. Sliding interval tells you when to calculate the window, right?
Yeah.
The window length tells you how many batches of data do I take, right? Now, the actual initial parameter is when to read the data. So that we have, if you look at our last program we did, right? The stream sample here, this which said here, seconds of 5. This is what I am going to read the data at 5 seconds interval, right? So now when I'm calculating this, there is a sliding interval, there is a window length, and there is a reading interval. Just 1 minute. Give me 1 minute. Okay. So there is something called batch interval, right? Let me put that down here. Okay, so the batch interval is what tells you when to read the data, correct? Now, the window length and sliding interval should be multiples of batch interval. Otherwise, it will not be able to calculate. What that means is, if my sliding interval is 10 seconds, okay, and my batch interval is 7 seconds. Now, what will I do? For 7 seconds, I get one batch data. At 10 seconds, I need a sliding interval. So at 10 seconds, I need to calculate this part, right? Sliding interval I've defined as 10 seconds. Now I need to calculate this window now. So I need last 30 seconds. But here, since the data is 7 seconds, I lost 3 seconds of data. That's still not come in now. It will come at 14 seconds, correct? Okay. I have defined batch interval as 7 seconds. So I get data at what intervals? 7 seconds, 14 seconds, 21 seconds, etc. Correct? Is this clear?
Correct.
Yeah.
Every 7 seconds, I'm getting the data because I defined batch interval as 7 seconds. So I will get data at every 7 seconds. Correct?
Yeah.
Yeah. Now, what I'm calculating, sliding interval, I said 10 seconds. So once 10 seconds is passed, I need to calculate a window. Now at 10 seconds, what do I have? I have a data only up to 7 seconds. I don't have data up to 10 seconds because 3 seconds data is still lag. It's still on the way. I have not gone and read it because my interval is 7 seconds. So I will read it only after 7 seconds. So I'm losing 3 seconds of data here. Correct? So that is why what it has to be is the sliding interval and window, the window length, both have to be multiples of the batch interval, which means that for simplicity's sake, if I keep say my batch interval as 5 seconds, okay, so this is how I get the data. Now at 10 seconds interval, I get the data till here, 2 batches. Okay. Now my batch window is 30 seconds, right? So at sliding interval 10, how many batches I have? 5 and 10. So I have only data up to last 10 seconds. So I will take this and calculate. But as we go ahead for 30 seconds, I get the data because I'm reading every 5 seconds. So I get all the data for 30 seconds. And then at each sliding interval, I can calculate the windows like this. Okay. So to summarize, all you need to remember is to avoid the data inconsistency, the window length and sliding interval should be multiples of batch interval. So batch interval I have defined as 5 seconds. Okay. So your sliding interval can be 10 or 20 or 30, whatever. And your batch, your window length could be 50, 70, whatever, just multiples of this. Okay. Guys, any questions? You get the concept? Batch interval, sliding interval, and window length. These are the 3 main concepts of your streaming data. Hari, Leela.
Yeah, clear. So basically,
No,
we take 10, 20, 30 as the sliding interval. Then here in this case, you have again, suppose you're taking at your window that's 10 seconds, right?
I didn't get your question. Can you come again?
No, your interval is say 10 seconds. Then your window length in this case, in this particular example, would be how much? Like 30 seconds, right?
So there is no limitation on how much it should be. The only limitation is that your batch interval, it should be a multiple of batch interval. That's it.
No, I'm saying in this particular example, if I take, say, the interval as sliding interval 10 seconds. Type 1 is 10 seconds. The interval is 10 seconds, right?
Yeah.
And then your window will be every 30 seconds.
Yeah.
Is that correct?
Yeah. So that's what I'm saying.
Yeah.
Your window length can be more than 30 also.
Also, yeah. But it has to be 40, 50, something like that, or 20.
Yeah.
Multiples of the your sliding interval.
No. The window length need not be multiple of sliding interval. It only has to be multiple of batch interval. Both of them. See, sliding interval tells you how often do I need to calculate the window. Okay. Then the window length tells you how many batches of data will fall in that window. Okay. So if I say my batch interval is 5, okay, my sliding interval is 10 seconds, and I say window length is 15. This will work fine because every 10 seconds, okay, I am trying to read the data for last 15 seconds. In last 15 seconds, how many batches of data did I get? 3, because I am getting one every 5 seconds. Okay, so if I change it to 25, right, this is still fine because for every 10 seconds, I am calculating the data for last 25 seconds. In the last 25 seconds, how many batches did I get? 5 now, because 5 seconds I'm getting. The sliding interval and window length does not have to be multiples of each other.
Okay, only the batch interval and the window length.
Yeah, the batch interval, so the sliding and window length, these two have to be multiples of batch. Because we should get the complete batch data. We should not miss the data somewhere, right? That's the only limitation. So now if we take this example, every 10 seconds here, my batch interval is 5 and my window length is 25, right? So at T5, say at T5, okay, if at T5, how many batches will I have? 5. So 1, 2, 3, 4, 5. So all these 5 will be part of window 5 if the interval is 5 seconds. Okay. Or if I say 20, now at T5 window at time 5 will have data from time 2, 3, 4, 5, only 4 batches. Time T1 will fall out because last 20 seconds 5 is the batch interval, so I get only 4 batches at time 5, right? Yeah. So this depends on how you define these intervals. Okay. Now, how do you define these intervals? Again, is based on how much data is flowing in. So this all comes with actual deployment and testing of your application. Are we getting too much of data in a short time, or are we getting very less data? So do we need to increase the interval, batch interval, or do you need to read more often? So all this depends on the volume of data that is flowing in and how we process that data. Or do I need to increase my processing because I cannot deal with the data, it gets backlogged. So if I have to read that more data, then my interval has to be low, that I need to read every 1 second, but then I cannot just read and keep it. I need to process it and push it out so that I take the next batch data and then start processing that, right? So that is all about your window streams, windowing. Now, there are some transformations, just like you do on a batch job, say all your map, all your business logic, or all those. You can also do those transformations on the stream data at a particular window. Again, so if we go back to our stock market example, right? So we said I want to see the stock price for last 30 seconds and I want it to be refreshed every 10 seconds, right? So I get the data for last 30 seconds, but at the same time, say I want to see the average of that data, okay, for that window, each window average. So how do? I can do a transformation. I can do just like we did in the batch. We can convert that data within that 30 seconds into a data frame and do an average on that, or any function that we apply on that data as a data frame. If not the only price, say if I have more attributes, more elements that are coming in the data, okay, apart from say if I have the data that is weather data that is flowing in, for example. So weather data, if it is flowing, I will have more. It's not just the temperature. I will also have the region. I will also have the timestamps, right? So I can say I want to calculate the data in the last 1 hour, but I want to get the average temperature by state. So I can group all the data by state and then do an average. So within the streaming data, if I want. So I can get all that for last 30 minutes. I want to see how the average temperatures are across each state. So I can group that by state within the streaming, by group by state, and then get the average temperature, right? So all that you can write, just you do in the batch, just like you are doing in a batch, reading the file and creating a data frame. The same thing you can also apply on the streaming and onto a window of data. Okay. So any questions, Leela? Do you get the concept?
Yes, sir, and I got the concept.
Yeah, okay.
And it's for like milliseconds also, like it's based on our input data, we can calculate, right?
Yes, yes. So that's all. It's based on the volume of data that is flowing in. Okay. Normally, you can take 1 second of batch intervals to read the data every 1 second, and then process everything within that second and push out. Or you can also have, because it has to store the multiple batches of data in the window, right? So if you put a too big of batch interval or a window, okay, so if your batch interval is say 5 seconds and your window is 1 hour, okay, so which means that you get about 20, or say every 5 seconds, and then if you have 1 hour, you get probably 12 batches per minute, and into 60 per hour, right? So if you even if you say 1 minute, so you get 12 batches of data. It has to store in memory because it has to fit all that into a window, right? So it cannot throw out that data out of memory. So it has to keep the data accumulating in the memory, right? So if your window length is too big, then the data it has to keep in memory will also increase, because you have to do some calculations on the data of all those batches within that window. So all that data that falls into that window has to be in the memory, right? So that's how you need to adjust tuning. So should I increase my interval? Should I decrease my window? Or should I increase my processing using my cluster in the Spark? How many threads, how many executor machines do I need? So all that is part of your exercise, the tuning exercise when you work with actual application and the data.
Okay.
Okay. All right. So we will look at the Windows operations data, you can see, but most of the it's not so, as Srini has mentioned in our last sessions, it's not so matured to use this streaming data yet. Most of it is still in the initial batch jobs. So most of it is using only the batch jobs. Even if they're using streaming, most of it is just connecting the data pipeline and doing transformations. I don't see anybody doing windowing kind of operations except for some specialty industries, just like I spoke about weather stations or the highly critical data like the stock market, right? So those kind of things it would be using, but very minimal application as of now. But still, it's good to know the concepts and how these things work. Okay. Now let's do a small sample of transform, right? So we know that we get the streaming data. So for the streaming data, we do the Sparks configurations and streaming context of Spark configuration. I'm reading the data every 5 seconds. Okay, so this we have done in our last class as well. Now we get a streaming context. Now I want to read from the socket stream. So if I want to read from the socket stream, that's the same thing that we do. Read from the socket stream netcat that we will use. So localhost at this port, I'm going to stream the data for it to read manually. Okay. So once I read this data, so this is a D stream, correct? Now, what did we say? D stream, what does the D stream contain? What does the D stream contain?
Pair of RTD.
Yeah, correct. So, good. So you have a stream of RDDs coming in the D stream, right? So I say D stream words equal to line stream. Okay. Now on the D stream, I can do a transform. Okay, so it needs a transform function, just like your map. Okay, so I will do. So what is the each element in the transform? As we said, D stream is a RDD, right? A line stream is input D stream of RDD, and each element. So if I say what is the element of the D stream is a continuous stream of RDDs. So each element is a RDD, right? So this, if I take each element is a RDD of string. So this is a D stream. Inside the D stream, each element is a RDD of string. And for each RDD of string, what I'm doing, well, filter RDD equal to element dot, I'm writing a filter function. I can do a filter on RDD, right? We have done RDDs. So I'm doing a filter on the RDD. Now, what is the element of RDD? See here, it is a string. Now from D stream, we have come to RDD, and within the RDD, we have come to the lowest level, that is a line, which is a string. Now, x dot, let's say, equals spark. Okay. Now I have to return this RDD back. See, you have to be very careful. Observe here, when you do the code, you keep doing your code looking at what data types is going in, what data type is coming out. How do I need to do a transformation, right? So transform will always again return a D stream of the same RDDs. So if I do here, it is D stream of string. So because we have removed that strings from here. So same thing here, input D stream of string is same as the D stream of string here, right? So inside the D stream, we have taken out each RDD and applied our filter on the RDD. That is what the transformation is doing. So transformation runs on each RDD internally. So I return that RDD string, which will again go back to the original D stream of string. Now here, I want to just print this. Okay. Okay, so this is just like our last program where we read from the socket stream, but in the last program, what we do, we have done the reduce by key. Where is that program? No, I don't have that anymore. So, but we read the data from the socket stream. We have used reduce by key on the D stream itself, and then we have calculated the count, word count, right? Now here we are using a transform on the D stream. So D stream transform function, inside it we can write any function just like we do for RDD to do a transform, and then we are printing it. Okay. So similar to transform, you can also do a join any RDDs here to this D stream. Okay, so you can say so let's see here, streaming context. Okay, yeah, let's first run this and then see how do we transform works, and then in future classes we'll explore more transformations just like we did on RDD onto the D stream. I mean, you can also do a practice and try it out multiple transformations on this. Okay, so let me go to transform. Okay, so I have not make it a streaming. You remember we have to do write two functions here. So that it keeps running continuously until we terminate it. Okay, so now this is running. We can put input data. See, it won't read because we have applied the filter on that, right? So we can put more. So it gets only that filtered elements here, right? Because we put the filter here. So what is important here is that you write your business rules here out of the data that is coming in. You can write your business rules to filter out what data you want to actually take ahead, process. I don't want to take all the data that is coming in. If we go back to our stock market example, I can put here filter for a particular stock, right? So I just want to take Apple stocks and do my processing or trending charts for this. So I can filter out the data here, or if I don't want to use some of the stocks, or I can do whatever the price, I can say take all the stocks only whose price is greater than this, or by percentage, which have increased by 10% or 1%, kind of a thing. So all those filters and business rules I can put here to transform the data. And once I get the transformed data here, I can do whatever I want, or I can add joins. I can join a particular data for any logs. If I get if the application wants to have a header data, right? So, but the streaming data that is coming in does not have headers. So what I can do is I can create header data here and join it to the incoming data, streaming data, and send it out. So all those kind of operations we can do here. Okay.
Okay.
Yeah. So any other questions? Of course, we will continue to do more practice, more programs in this going forward. But that's what I said, when we go connect the sources, data sources I have. Where is that? Yeah, here. So more and more data sources we get here, we add. We will continue writing both the jobs, the batch jobs to serving layer. First we will connect batch job to serving layer, and then we will connect source, streaming, and serving layer all together, end-to-end pipelines. And later, as a more advanced, once we are done, we can also look at as a project for you guys to explore and put ML jobs into these streams in the Spark streaming as a live. So to see when the data is coming in, how you can apply your ML library and come out with a decision based on the input data. So that would be the ultimate kind of towards the end of the training sessions. That's how you could get more hands-on, more confidence working, getting the data pipelines, and putting your all components, serving layers, your data ingestion tools, your streaming, and then put your ML, whatever we have learned, the algorithms, ML algorithms into that, and see when the data is coming in, the streaming data is coming in, how your ML is giving you the output for each of the data that is coming in. So that is something you can take up as projects towards the end and work on that.
Just one question: the streaming layer. Where are we reading this streaming data from? This database or streaming new stream data, right?
This one.
Yeah. So this where we are reading it from? How will we be able to read it?
Yeah, that's what I said. This new data, we can read from all of these, from Kafka, from HDFS, from S3 files, from Twitter, all this. This is a fork here. You can take it to a batch or you can take it to streaming.
Correct.
Okay.
Yeah, batch I understood. We can take.
Yeah, the same data you can. We will see. We will connect and see in the next class how to read Twitter data, and then we will slowly introduce Kafka also into that, and then we will get onto that. Okay. So yeah, that's it. So we will continue parallelly, taking each one program into the streaming and connecting in each of sessions. But for now, we will get started introducing with the other topics. Okay.
Okay.
Yeah. So any other questions here before we jump on to the other one?
You also mentioned about this Elastic, so that you will be taking now? Or?
Yeah, we'll start now. Okay, fine. Just give me a minute. Let me get some water. We'll get started. Okay, let's switch the context. Now, as we have seen, there are multiple serving layers here. So one of which is Elastic, one is Cassandra. So we just mentioned two here. There are many of them. As you can see, you can use a HTTP client where you can publish the data to. Okay, HTTP APIs, you can publish the data to. You can have a MongoDB here, or you can even have an Oracle database, RDB, anything that can store the data where your applications are reading the data from. Correct? So most of the applications read from the data stores. Mostly you can say from MongoDB. Is used for serving layer for most of the web applications. Cassandra can be used also for either web applications or from the analytics dashboards applications. Elastic is used mostly also in the front end applications where you need to search for the data. The indexing or searching is multi-directional. which means that the search is not defined. Okay, it's undefined search. The best example and most apt is where you go to shopping websites and do a search on your products, right? So the search is not unidirectional. It's not by structured search. It's unstructured, which means that you can do a search on a brand, on an accessory, on a price, or whatever. But if whatever is matching, it would always get it back, or results from all. If you say just a bat, okay, so the bat could be a baseball bat, a cricket bat, tennis bat, right? Racket, anything. So it gets results from all of those and displays it on you for you to select from. You've seen that shopping websites, right? Most of the shopping websites. So if you go here and say here, right? So if I want to say the category, I don't say any category, I don't say anything. If I just say dress, so you get all of these categories, right? So most of these is done, the underlying engine that works on this search is not saying this is based on the Elastic, but most of things like this will work on the Elasticsearch. So what Elasticsearch does is it indexes all the data you are putting in, so that it is easier for the application to search based on the indexes. Okay, it just speeds up your search. That's all. That's as it stores. Now, as and when you put the data into the Elastic data store, it will index it immediately so that the search becomes easier. So that's where the main concept of Elastic has come on. So how it does, the underlying is again the Lucene Solar engine, the Lucene engine that works under the Elasticsearch, and it's just a data store where, just like your Cassandra or Oracle or any other databases, where you can put the store the data into, and the applications can search and get the data from. Now, what kind of search? What does it Elasticsearch has is an Elasticsearch data store is a cluster, just like your Spark cluster. Elastic is also a cluster. Okay, so it has multiple machines on the cluster, and when you put the data, it indexes the data and stores across the cluster. We will discuss all the features, but this is where the introduction is. Now, when you put anything onto the Elastic search engine, so the data is all indexed and your applications can retrieve it faster. You can also define how to index the data and what you need to do the data. Now, if you go to say another site, GitHub, we all know GitHub, right? So this is the GitHub, and I search on Scala. Okay, so all this is actually based on the Elasticsearch. Okay, so your results, all of these, and by categories, everything is based on the sorting. Everything is based on the Elasticsearch, the pagination, all this done. This is one example where Elasticsearch is used in the web applications. Okay. Now, how do we define the Elasticsearch data? What happened? Is it just get stuck? One minute. Okay. So what is Elasticsearch? It's a schema-free REST and JSON-based document store. Okay, it's one line definition of what Elastic is, which means that you don't have to define a schema when you put the data into it. You can automatically add more attributes or remove some attributes, whatever is available when you put the data into. The REST and JSON based means that it uses a REST API to put the data or to pull the data out from the Elastic. And obviously it is a JSON based, the data you put. So what is JSON based? We will see in the coming slides how to put and get the data from the REST and JSON based API documents. So each of the input data record we put is called a document. Okay, so I will also show you. If you look at this, so the structure of the data, the attributes together, it's called a document. And all of these documents together will form an index. Okay, see, how do you look at these things is obviously you will try to compare with our RDBMS, right? So that make it our understanding easier. So how it stores is you have a index, and within the index you have a document, which means that your index is equivalent of a table in RDBMS, and your document is equivalent to a record or a row of data in the table. Okay, so you have index and documents. So we will come to it. So schema free, you can put, there's no restriction that this is the schema you have to adhere to. Then you have REST APIs to put the data, and it is JSON based document store. So you store documents and you get the documents out. It is distributed and horizontally scalable, which means that, as I just mentioned, it's a cluster. You store the data onto cluster into number of machines. So most of the tools that are coming in the big data landscape are cluster based. Okay, just like your Hadoop, you can keep adding multiple machines. That is what it means, horizontally scalable, and it is a distributed, which means that your index, or for example, the same like table, right? A table in RDBMS is same as the index. So your index need not be on one machine. Your index can be distributed across multiple machines in the cluster. So some of the documents can be on one machine, some of the documents can be on another machine, but all of them belong to one index that is distributed. So your data, your documents are distributed across the machines in the cluster. Okay, so it's an open source, which means that it's free if you want to download and use it. Zero configuration. This is basically if you want to do a single machine or trial installation. Of course, in a production environment, you do want to do some configuration, but to just get started, you don't need a configuration. So it is internally written in Java and extensible. That's fine. We don't have to worry about it. You just need to know what it is written in. So when we come back to zero configuration, what it means is that you just download the file, unzip it, and start it. You are ready to go. That's it. Download, unzip, and start. You don't need to do anything on the VM, at least. You just need to find out the version which works, and you can start. So this is how it fits. When you do an Elasticsearch, normally it is evolved into something called, first it started with Elastic, now it's evolved into a ELK stack. They call it ELK stack: Elasticsearch, Logstash, and Kibana. Okay, where it is mainly used, this stack, of course, and again, there is no hard and fast rule that you have to use all of these. It's up to us. You can only use Elasticsearch. You don't have to have all Logstash, Kibana. You can have only Elastic, or you can have only Elastic Logstash, or you can have only Elastic and Kibana, whatever you want to. Now, what this stack helps you is, you have most of the logs that are coming in your production environment, where you want to monitor and search for troubleshooting. For just one example, so if you look here, there are services that are generating logs, The Logstash is actually a data pipeline that will push the data into Elastic, or these logs into the Elastic. Okay, so it's just indexing the logs so that it will be easier for search. That's all it's doing in the entire thing. You get all the logs from various jobs that are running, or various networking logs that you're getting, various data that is coming in from the external systems that is hitting your network, or various requests that you are processing. Various servers, or users that are requesting, say, service like your videos that you on YouTube, how users are requesting videos and watching. If the video does not play, all right, so there is an error. So you log that error. That error is generated. So you want to you want to analyze that error. So all that various logs that are generated will get into Logstash, and the Logstash is just a pipeline that will ingest and put it into Elasticsearch. Now, once the Elasticsearch is done, so here, this is the ingesting part, this is the storage part, and this is the visualization. Kibana is the visualization, the interface UI, where you can browse through, search for what kind of errors, at what time, in last 30 minutes or 15 seconds, what are the errors, where, say, network error. You want to search for network errors in the last 15 seconds. You want to search for, video errors in last 15 seconds. So all that you can do from the UI, from Kibana. And that search is based or pulled out from the Elastic, and the data is put in through Logstash. So this is together will give you a solution. Okay. The same pipeline you can also build from our Lambda architecture. So instead of Logstash, you can use your Spark streaming here. And as and when the logs are coming in, you can read, process, and push it to Elastic. And then UI, you can use anything to read from Elastic. Kibana or any other dashboards if you want to use from Elastic. Web UIs, anything. Okay. So that is where the Elastic fits in, Elasticsearch. Okay, so mostly the applications where you use Elastic are the web-based ones, which access the data using the REST API on the Elastic. Okay. Now what it provides is the unstructured and structured search. You can do both unstructured search as well as the structured search, which means that specific attributes, or undefined attributes also you can search for. Sorting, pagination, and suggestions. So these are the ones we have already seen here, right? So sort is done here. So this is the application that it has done sort based on. So this is the sort feature. Pagination is this feature where you get more results and you can do pagination based on the results. And this is all the categories. Structured search. This is the structured search. You know what you're searching for. And then we have also seen here, the suggestions as you type on based on the search. Okay. So these are the features. So any questions in general about Elasticsearch? Anyone? Harish?
Good.
Kiran? Shiva?
Harun, is it like just a string search will work for this? If I go to the Kibana and just search, I can just search any string or particular particular format of searching is there?
See, there are various ways how you interact with Elastic. Okay, there's one command based. You can do command based. There are some APIs that Elasticsearch gives you that we will explore now. I will show you how you put the data, how you get the data, and how you search the data based on the APIs. So it gives you a command line API using curl commands, you can interact with the APIs, or you can use it through browser, through your URLs. You can interact with Elasticsearch and get the results, search results from the Elastic. It also gives you the connectors where you can get the data, read the data from Elastic from the Spark. Just like you are reading your Hive data tables or your files, you can also read the data directly from the Elastic, from the Spark, and you can also write it to Elastic from Spark. That also we will see. Now, when you talk about how do we search is what you define in your Kibana. The Kibana is a UI, right? So in the UI, you can define on what attributes you want to search, or you want to search a freestyle based unstructured like this. So it's implementation. Okay. So if you use Kibana, you can, Kibana is just a tool. You can choose to use it or not to use it. But if you want to implement Kibana, then you have to define the UI, how you want to search on based on what attributes. Okay. But our focus is not on these elements. Okay. I just given you, just you will have an overview. When somebody talks about Elk Stack, what does it mean? Okay. But our focus is not on Kibana or Lagstash. Our focus is only on the Elasticsearch. That is also limited to how we can access and put using the Spark, right?
Okay.
But I just want you to know that these tools are also available. Some companies implement the Elk Stack, okay, without any Spark, without any big data things, just Elk Stack. If they have a lot of networking logs that they want to analyze. So this is you must have heard about Splunk, right? So Splunk is also a tool which also works based on this Lucene engine to check the logs or to search the logs for a particular event or for a particular attribute. It's mostly used in the production support environments to troubleshoot. So same on the similar concept of Splunk, this Kibana Elk Stack works. So it makes it easier to view the logs or to search the logs or to search any data events in a huge based files. Okay.
Okay.
Yeah. So don't worry about this Kibana and Logstash. Just have to know the names and say the Elk Stack, how it uses. These are very small tools where if it all is there, you see any tool in a big data environment, you can learn in a week, not more than that. At least to the extent where you can use it, if you know the concepts.
You can customize the Kibana UI using different curl commands. You can predefine the curls and expose different ways of searching in the Kibana.
Yeah, so that's what, if you do a Kibana implementation, you're right, Hema, that you can define on what you want to search.
Yeah.
Okay.
Okay.
Okay, cool. All right, so let's see what Elastic is. So Elastic, you can download just the zip file. You can go to the elasticsearch.org and just download using wget. Okay, I have an old version. You can get latest versions. If you go to where is this? You go to elastic.co. Okay. I'm not sure. Elasticsearch downloads. So you can see which zip file you can download the latest version, whatever version you have. Okay, and these are the commands how you can say Just get download and unzip. That's all. Okay. So if I go here, so I have downloaded the Elasticsearch 242.tar.gz and then unzipped it. So when I unzip, I get this folder and I get all of these. And if I go to bin, there is a executable file called Elasticsearch. So 3 steps: download, unzip, start. So I'll just say Elasticsearch. That's it. Your server boots up and you are ready to use Elasticsearch. Okay. Now, if you see here, default is port 9200. If you say localhost :9200, if your server is running, you will get this kind of information. If you stop the server and go here, see, I'm able to connect. Okay. All you need to do is start the server and see at localhost :9200. This is where the default port are. Again, in the work environment, you can always configure which port you want to use to connect or to install the where the Elasticsearch will run. So this is what is 0 configuration. Okay, so all default it uses, and you get this information here. Now this is all download, set, ready to go to test your Elasticsearch.
Arun?
Yep.
So how does it know where the files are stored and how does it use the files in our system?
Which files?
He's talking about the integration.
The log files? No. So we don't have all that information now. There is no data. This is just we have downloaded. That's what I said. For configuration, if you have files, if you want to connect this data pipeline, that's a different. Then you have to install Logstash. Then you configure and tell the Logstash where your Elasticsearch is running, where you have to put these logs. Correct?
Yeah, correct. So
that's the job of the Logstash to do, or just the job of our Spark application to write the data to Elasticsearch. Right?
Yeah.
So, yeah. Yes, Hari.
No, what I'm asking is now for Elasticsearch also it has to store somewhere, right? The files or
yeah, it will store. Yeah, it will store internally. It will have. See, when you install it will, if you install Elasticsearch on a machine, it will store the data in that machine.
Okay.
Whatever
so that
data
we don't have to worry about.
Yeah, no. Wherever you put, right, that's internal storage. Otherwise, how can you search that if it doesn't store? It will index internally, and it stores the indexes as documents as indexes.
But somewhere I have to say, these are the files that
is the consumer applications headache. Like if you want to use Elasticsearch as your searching tool, your underlying system, whatever it is whether it is a Spark or Cassandra, whatever it is, you have to ask that application to write to Elasticsearch code. Okay, the configuration at the other end, not in Elasticsearch.
Just look at this. Take out this Elasticsearch and put an Oracle here. Okay.
Yeah.
If you have an Oracle database,
right.
Then how do you put the data in there?
Yeah, you put that into the table.
Right. So, do you know where the Oracle stores? Do you want to know where the Oracle stores the data you put into the table?
No. What I'm asking is, see, if I put some physical files like log file, for example, in my
log file. Yeah, that's what we will come to. It's a log file. When it reads
or
the log,
any data,
it does not.
for that matter.
No, it does not move the entire log file there. It will move in this format. It will has to move as a document, as a record into an index. It will create an index for a log.
Right.
It reads.
So, for example, I want to put a data into the Elasticsearch, into the index. How do I do it?
Yeah, that's what we will come there. That's what I'm showing. See, there are multiple ways. One is you can put through your command prompt, or you can put through your Spark application, or you can put through your Logstash, or you can put to anything. See, Elastic gives you an API. You can use that and push the data into Elastic from anywhere. Any application can push as long as it can use that API. Now, what is that API is REST API. You have all your REST API methods: put, get, delete, search, all of those. Okay. So we will explore it. So let's put some data into it and see. Okay.
Yeah. High level, I'm fine.
Yeah. So let's put some data. So we'll go step by step. Okay. First thing is we installed Elastic. We have started the Elastic server. So it's running, and I can see the Elastic is running here. Okay. Now first thing is I want to create a index, right? Index, the documents will be stored in index, just like table. I have a database or a schema. Now I want to create a table. So just like that, I want to create an index. So here you can specifically create an index, or you can directly try to put a document in an index. It will automatically create the index for you. Okay. So when you say the format here, so if I want to put this data into Elastic, right? I will say put is my method. Localhost, this is where your Elastic is installed, the URL. In production, if you have a machine where you have installed your Elastic, you will give the IP address of that machine and the port where you have configured your Elastic, right? So you give IP address and port, just like when you're connecting from Oracle client, you will tell the client where your host URL is and what is the port, right? Same thing here. Then comes your index, okay, and your document. These are all the documents. So this is the index and the documents in this. So I have a store. In that I have an item called book. The same thing you can have in the store. You have a TV. So each of these is a different index, sub-index you can call. Okay. So first let's try to put one here. Okay. Let me get this. So I just go to any of, let's go to command prompt here. Okay. And parse exception. Okay, let me. Okay, so I have put the index, the book underscore, one is the ID, and -d, this is the document I'm storing. So the document will have the just like your columns and values, right? So title, author, started, pages, all these attributes. So I have put into the index. Now I can go here and search for books. So I have story/books. That's one. So this is how I'm searching with the ID in the store, book with ID 1. So you can see title, whatever we have put the data. So your application will also search this index, Elastic Index with this when I want to search for book or for the ID 1.
So do I have to know the ID each time I have to search or how?
No. You don't have to know. So there's a different syntax. I'm just showing you for simplicity. There is a syntax to search like this. So you don't have to know the ID. So I'm searching with the attribute called Elastic. So where is the Elastic? It will pull out. This is the title and this is the index. And this is another title. There's already one title here. So you see now I got 2 results.
Yeah, but that is on the title, right? You can search for the author also, like for example.
Yeah, you can. So see what I'm seeing here. What did I show here is like if I want to search just on Elastic, you get both the results. Okay.
Right. If you search for NAT, you will get the first one, right?
Yeah. You can search anything. Yeah. Okay. So the feature of Elasticsearch is that it does not ask you on which attribute you are searching, right? Here you're searching in the title, but when I put NAT, it searched for the author. So it searched all the attributes for this search string. So that is the unique way. So that is why when you look at these stores, right, when you search for any in the here, okay, if I say what do you call say if I say brand, right? So the Nike can be in shoes, socks, watch, everything. It search all the attributes, all the indexes, right?
Yeah.
So if I say just say blue, so blue can be a speaker, can be headphones, play DVD player. So these are electronics, or curtains. See the curtains and headphones. So blue can be anywhere, right? So that's how the indexes are searched, the attributes in the Elastic. Okay.
So that is a definitive, advantage over the traditional RDBMS search, wherein you cannot do that.
Exactly, because it is all structured search, right? In RDBMS, you have to give which attribute, and then you also have to say whether it is equals or it is like or it is contains, right? Correct. So you have to qualify with so many things, but here it is not like that. So here you can just search on any attribute. Of course, you can also configure, even within Elastic, you can configure which attributes you want it to search. I mean, I can exclude some of them. So when somebody searches for a string, I can say don't include the store name. Okay. I don't want to search against the store name, but rest of the attributes, or just include all of the rest of the attributes.
Correct.
I can say I can also configure all of that. It gives you option to do that as well. Okay. Similarly, so let's continue. So I want to put so this is already there. And let's see, do we have a TV already in there? Let's search for that. Yeah, so we already also have TVs. So I can search for a brand similarly, right? So this is how you can read and search in this. Or you can also search on the command line. Just like you're searching from browser, you can also do the same from the command line.
Yeah, but here it's also important how you structure your, I mean, I cannot say tables here, but your index.
So index, yeah, that's what I said. It's schema-less, right?
No, that's what I'm saying. Here it's important how you structure your index. That's what you said, right?
No, so that's what I said. See, your index is your schema here, what attributes you have. So it's schema-less. When you're actually adding, you can add more attributes. So if I have author, started, pages, I can also add type here, hardbound or paperback.
No, that is a record. That's a record you're talking about. What I'm talking about is the store. For example, the store, what you mentioned here. And so store for me is a database, and book is the table, which is compared with the RDB. So
right.
It's important how you store your data in this structure.
No, that is internal. You don't have to explicitly tell Elasticsearch how you want to store, or you don't have to say how my structure of the book looks like. What columns are there? What is the data type? You don't have to do any of that.
No, not the data type, but I'm saying, depending on your data, you need to store it accordingly so that the retrieval process is correct. Because it's not a relational database. It's going to be it's a total it's a different structure, right?
Mm-hmm.
So the way you put it in this format, is there a way you can define that, or is it internal?
No, it is internal. That's what I said. How it stores, how it indexes is all internal. You can specifically create more advanced settings, configuration on particular fields, on particular attributes. You can make some of the attributes mandatory by explicitly defining that any document that is coming in should have this attribute, like author or title is mandatory. So there are some specific configurations that you can do, but by default, all you have to do is the structure is you have to conform to a JSON structure, which means that name and value pairs for as a column. That's it. This is the document here. As long as you have this structure, that's all you need. You don't have to tell how to store it, where to store it, what to store it. That is what Elastic
that will handle it internally.
Yes.
Okay. That's good. Yeah.
Some documents, because we said here, right, it is schema-less, right, schema-free. So some documents can have authors, some document may not have author. I mean, it's optional, each of these.
Right.
You can add, for some books, you can add more attributes. Some documents you can have less. It's not that all attributes should have same attributes. But you can also specify some configuration saying that these attributes are mandatory, or these attributes are specifically indexed, kind of a thing. Okay.
Yeah, because the reason why I was prodding a bit into that is because traditionally most of our data, like our systems are in RDBMS format. So we need to somehow get that to this kind of, even if it's a batch processing or if it's, streaming, we need to get that into this kind of a format. So there, there could be a challenge there. That's what I was wondering.
Format, I don't think it's a challenge to get into format, right? So if you have a table, you have say 10 columns, and then you convert it into JSON. So I'll give you an example that we already did. And if you remember, we have read the files, right? CSV files.
Yeah.
We converted it to JSON format.
Correct.
And then we wrote the JSON file back onto the HDFS.
Yeah.
Right? Now, remove the first and last part. You're reading from the file. Instead of reading from the file, you connect it to RDBMS and read that. Right? You get an RDD or a data frame. You convert it into JSON. And on the right side, you are writing back onto HDFS. Remove that HDFS, connect it to Elastic. It will automatically write your table data as a index into the Elastic. That's how you connect the pipelines, right?
But what about my internal, for example, a customer, a supplier, and all those related tables, like those kind of
so that part is, I understand. So that part is your data modeling. Okay, you have to model how you want to have your.
I cannot bring all that into this.
No, you cannot recreate your relational. You cannot recreate your relational database into an Elastic. So you have to do some data modeling. Flatten your tables.
Correct.
And flatten and replicate or duplicate your data and then write it. So that's what it is, right? When you get onto HDFS, you flatten your tables. You try to take out all the joins and come up with a flat, right? So even
that is what I said. There is a challenge there because we are used to this RDBMS, unfortunately, or whatever.
Even if you move to a Mongo, it's a new NoSQL databases. It's a shift from
Elasticsearch is widely used only for NoSQL databases, not
Correct.
on top of RDB.
Correct. So it's a shift. It's a mind shift
One more drawback on NoSQL databases is they don't support secondary indexes effectively. Like Oracle, all of the NoSQLs cannot provide multiple index columns.
Correct.
Either primary key or partition key or clustering key are only the three options that we have for NoSQL databases. So to extend the capabilities of searching on top of these NoSQL databases where the key columns are not the primary key or partition key, we will add Elasticsearch on top of these clusters.
Correct.
Actually, I absolutely agree, but I'm just talking about my just in the case of the actual scenario, what we have is a RDBMS. So that is where my.
So yeah, I understand that. I understand, Hari, what you're talking about. So I also worked with Hema when in the Apple, right? When we did Oracle database conversion to MongoDB, right? So data conversion from Oracle to Mongo, because serving layer is easier from Mongo because Mongo is also a NoSQL document-based REST API-based store, just like Elastic, whereas Oracle is RDBMS. So when there is a service query to get data, when you go to Oracle, you have to, as you said, right? You have to join all the tables, get all the data, structure it, and then send it. When you move to Mongo, all that is done when you write to Mongo, right? All that joins are done if your document is flattened, and then you write the entire document into Mongo. Now, when you serve, you don't have to do any joins. You just pull the document and give it. So that kind of modeling you have to do when you move from SQL to NoSQL. Obviously, you have to do that modeling, how you are going to represent the data in a NoSQL. You cannot directly lift and shift all the tables as indexes into or documents into a NoSQL database.
Correct.
So there is some team architects, consultants, and business analysts sitting and doing that transformation, doing the data modeling, and then you do the actual data migration from conversion from records to Mongo documents and
Exactly.
so
yeah.
So we also used Kafka, and we also used Spark. Then some Java-based applications also to pull the data from RDBMS, convert or transform. So you can use your Spark, and you can pull the data from RDBMS using the connectors. And within the Spark, you can do all those transformations, build a document, and then push the document into Mongo using a Mongo connector.
Okay.
So all these connectivities are available. You need to pick and choose the data pipelines. But as you said, we cannot do lift and shift. You have to always, that's what transform the data means. You have to transform from SQL to NoSQL.
Correct. Okay. Thanks, Arun.
Yeah, no problem. Thanks. Okay. So, so these are the get and the transformations here. I think we will take a break. It's almost 10 a.m. PST. We'll take a 10 minutes break, and then when we come back, Hema will continue. You have Hema? Okay, so Hema will continue with the part. And in the next week, we will continue this revisit, and we will connect the Spark and Elastic next week. And we write some programs to read the files and put the data into Elastic and read back from Elastic, and also look at exploring connecting the data from Spark streaming to Elastic if possible. And then we will also try to introduce slowly the Kafka messaging system also in the coming batches. Okay, so guys, is it clear? How do you feel? You have any questions? Are we taking progressively one step at a time, getting the complete picture? How do you feel? Are you okay with the space and the style of learning?
Yes, sir.
Okay. So you're feeling comfortable, right? Nothing overwhelming or things that are beyond.
Yes, sir. Comfortable.
Okay, fine. Okay, guys, thank you. Let's take a 10 minutes break, and then when we come back, we will explore more.
Thanks, Arun.
Join back at 1:15.
Yeah, it's almost 10:15 will continue.
Thank you.
Thanks, Arun.
Yep, thanks, guys.
Thank you.
Thanks, Arun.
Hello. Mute bit. Hello.
Hello.
Yeah.
Hi.
Hi. So, are you guys able to see my screen now?
Yeah.
Okay. I'll share you 2 files first. Okay. Meanwhile, download this data and try to access this code. Okay. It will take some time because it's a huge file. First one is the data and second one is the code. Okay. And today we are going to discuss about multi-classification algorithm. Okay. Okay. We already know that there are different types of algorithms which are broadly classified into classification algorithms, clustering algorithms, all these things, right? So in classification algorithm, till now we have seen binary classification where our output label will have only 2 values like yes or no, true or false, any of the 2 values, right? X1, X2, something like that. But there are some cases where we may expect more than 2 results, which is also predefined label. This is a labeling algorithm. In other words, it is called as supervised algorithm, where we already know what will be our output, or our output is classified into these classes, different type of classes, right? So these supervised algorithms or classification algorithms can be of type binary classification or multi-class classification, where the label can have more than 2 values and number of values, right? Like this, where we have this triangle, one type of class, rectangles, another type of class, and these x's, another type of class, right? The practical examples for these classification algorithms will be prediction of the weather. Okay, if you see the weather prediction, you can predict whether it is sunny, whether it is windy, rainy, cold, or windy, right? Like maximum it will be 4 or 5 classifications. It will not be anything other than that, right? We already know that only these type of weather conditions will be there. So we broadly classify that into these 4 or 5 categories for weather prediction. So that is one type of multi-classification problem. If you want to flag your emails broadly into different categories, okay, for some advertisements, some financial things, you broadly categorize into 4 or 5 groups, okay? Then you can mark it as another type of multi-classification algorithm, right? So today what we are going to do is, we are going to explore this. Data which has handwritten numerical values, and we want to predict which type of numerical value it is, okay? This is the label, okay? 5, 0, 4, 1, 1, all these things. The first character is the label of this remaining part of the row, okay? So what is this data representing here? This is the pixel coordinate, which is colored or like written. or darkened in the handwritten format. These are the pixel coordinates where it can find that there is some dark value. So
what is it represent?
What's the question? Can you please come again?
No, when you say dark value, what does it represent?
What are the?
When you say dark,
yeah, then we are capturing that XY coordinates here. Okay, like that for each character, we are capturing some 100 to 150 pixel coordinates where it is more darker. Okay, so
basically it's the RGB.
Your question is not clear.
Is it RGB that you are red, green, blue? The RGB values that you are showing here, or is it something like that?
Is it RGB? Okay, maybe it is. I'm not sure about it. I think it's only the XY coordinates. It's not the coloring value. Okay, based on the position where it is darkened, we are trying to figure out the numerical value image. Okay. So we have digits from 0 to 9, and we have a data of 69 MB. Okay, it's a huge data. We have some 60K digits like that. And each digit have some 200 or more than 200 coordinates where the pixel value is captured. Okay.
That's my doubt. You know, when it's a pixels, you see it like no RGB or those kind of classification. So
that I have to check actually. Yeah, you're right. It's a 200 by 200 pixels with RGB color. No, there is no RGB value for us, right?
Yeah, that's what I was wondering. So,
it's not a colorful image so that you can capture or you can recognize the type of the image, right? It's only the, maybe imagine it as a black and white, it's a white paper on which you are writing a black color digit, right?
if you scroll up, at what data, there you see the 200 into 200 pixels. That is what is the size of the image. Which RGB color they mentioned. No? So RGB is what determines the whether it's dark or whether it's a more bluish color or yellow color or red, green, blue. Red, green, blue is your basic three colors. So the data that you are showing is only the pixels. It's the size of the image. It doesn't have anything to do with the dark or bright. I think.
Okay. Okay. You're familiar with the idea of each pixel and an XY position into two-dimensional window. However, the array pixel has only one dimension. Okay. Load pixels. Okay, so this value is the color image is what you are saying, is it?
Correct.
Okay. Yeah, maybe that is right. Where are we? Okay. No, not this. Text pad. Yeah. So this value is the image darkness or color code at that pixel, is it?
No, this is only, I think, the size, pixel size. I mean, the the length and the how broad the image is, how long. I mean, length and breadth.
Okay. Okay. So this is how I'm not very good with this pixel capturing and all those things. Okay. So yeah, as he explained, who is that man? May I know? Like, who is that?
This
Hari.
Hari,
Yeah. So as Hari explained, this will be the length and width of the pixel with the color code, RGB color code that we are capturing here for each of the handwritten digits. And it is already like we already know that this digit is inferred as numerical digit 5. This is the sample data where the label for this is this 50. The first character is the label and the remaining is the data which determines this label. Okay. So are you guys able to download this file? It will take some time because it's a huge file.
Yeah, I completed downloading.
Okay. So as usual, we'll upload this data file to our Databricks cloud under data. Okay. And I got this path. Okay. After uploading this file. Don't worry, as it will take some time because it's a 69 MB file. Please confirm me on the chat once you download and upload it under this.
Yeah, it's sorry, in India it is taking a bit of time, so I'll tell you when it.
Okay, okay. Yeah. And also please keep this link open, the second one which I shared with you on the chat, where you have all the code.
So this MNIST decision tree underscore Scala is the code, is it?
This one, the second one is the code, Databricks Prod Cloud Front. Latest.
No, I got only one on the chat.
This Amazon WS URL.
Yeah, latest.html. Yeah, that's the one I downloaded. So that is
this
ongoing.
is the code. Latest.html is the code. Okay.
Code. This is the file. File I did
file
not get
is
it.
only this. 1 second.
I did not get that. Sorry.
This is the code. Okay. And
that's the code. Yeah, that I got. But the file to download.
Data is this.
Okay, I'll just do that. Okay. Right.
So for classification algorithms, we have multiple like different types of models that we can use to predict the classification or output label using a set of input features, right? And currently we are looking into the decision tree model, which is a type of classification model. Like our, as we already discussed, our ultimate aim or target will be to improve the accuracy of the prediction, right? So always what we will do, we'll get the data, we'll split the sample data into training and test data set. We'll train our model using the training data, and we'll pass the test data and predict the label output. And finally, we'll compare the actual label and predicted label and calculate the accuracy. And we'll improve our algorithm to improve the accuracy of the prediction, right? Is that clear? Any questions in this flow? So today also we are doing the same thing to predict a label which has more than 2 values. So it comes under multi-class classification model. Okay, the model or the MLlib that we are using for this classification algorithm is again decision tree, which we already used in last class for predicting a binary classification label. And today we are using the same decision tree model to predict a multi-class classification model. Okay. So are you guys able to upload the file?
No, actually it's showing quite a bit of time.
Okay, sure. We will wait, no problem.
Is there an extension? The file has an extension because I only got the name. There's no.
Yeah, there is no extension. It is a SVM lib file or something.
Okay, thanks.
Harish, are you able to upload the file? Surya?
Yeah, I have done that.
Okay. Okay, so simultaneously, like we'll run the code. Meanwhile, like people who have not uploaded it yet, you can try it later. Okay. As you all know how to use the Databricks cloud already, because it's already 1:36 p.m. Okay. So I copied this code, import code. This is the URL for code. Okay. Latest.html. Okay. So copy this import libraries and run it under the workspace. Go and create a new notebook with a name. Attach your cluster to it. Paste this import libraries code here in the cell and try to run this. Okay, you should be able to import all these libraries. Okay, today we are going to use decision tree classification model, decision tree classifier, multi-class classification evaluator, and some other supporting libraries like vector indexer and some transformations. Okay, so now I am going to read the data from this MNIST. What it will give? It will give a data frame to us. Okay. See, till now we are trying to test these models with very less data, maybe mostly some 1000 to 10,000 records. But now we have more than 50K records, 50K digits that we are going to use for our test data or training data. Okay. And also each digit is having more than 200 pixel values, which we are going to process. Okay. So we have read this file, and we got this file in the form of a data frame where we have one label of data type double and a vector of features. Okay. We have two values in our data frame. One is the label and the other one is the features. Features is the input which determines the label. Is that clear? Now, using this raw data.show, you can see each label and the features under this label. Okay. Are you guys able to read and display this raw data?
Yes, Seema.
Okay. So now, as we already discussed, we have huge data now. We have 60K records. Like, okay, we will print the count somewhere. Okay. So we have 60K records. Okay. And each record is also having multiple values. The features list is more than 200. Okay. So we are trying to use our vector indexer here so that we can index the values or data for faster and better performance. So if you see this MLlib documentation, you can see that we have this vector indexer. It says that index all features if all features are categorical. If the max category is said to be very large, then this will build an index of unique values for all the features. As we are processing huge set of data now, for better performance, what we are doing here is, for our features, we are defining a vector indexer. So we are indexing our features. Okay. So define the feature indexer using our vector indexer library. The input columns to this feature indexer is features, and the output column to this feature indexer is the indexed features. Okay. Here you are defining your feature indexer. So this feature indexer dot fit, what it gives to us is, it gives us a vector indexer model, but we need a data frame to process or to use it for our decision tree model, right? So what I did here is feature indexer dot fit of our raw data, which will return as a vector indexer model. Go to vector indexer model and we have a transform method here, which returns as a data frame. Okay. So we are indexing our features, fitting it to this indexer, and then transforming it to a data frame again, which we will use later for our decision tree model. Okay. So now this input data frame is having a label, which is an output, and indexed features, which we can use as input.
What is the max category?
This is the constant, like with distinct values. As we said, like we have vast ranges of data. Like we think that we will index these values, all these features with different maximum categories type greater than 4. If we have 4 distinct category values in your list, we will index that column.
Okay.
Okay, now we have our input features ready, which is indexed, and we have our output label ready. Now we have to split our data into test and training model, right? So we are using 90% of the data to train the model and 10% to predict the output. So we are splitting the data into 90-10 using our random split on the data frame. Okay. And now we are creating our decision tree classifier model. Okay. Are you guys able to follow me? You're able to run till this point?
Yeah.
Okay. So we have 53,861 as training set and this 6,139 as test images. Okay. We got this split data. Okay. Now we are defining our decision tree model using our input and output fields. Our input is our indexed features and our output is the label which we are going to predict. Okay. After defining these stages, we are creating our pipeline and we are fitting the pipeline to our model using our training data. It's still connecting, I guess. Okay. Is this clear? We defined our stages. We created a pipeline with those stages and we are fitting our model, running these stages on our training data and fitting the data to our model. Is this step clear? Okay.
But I don't know if it's the issue with the Databricks. It's been saying connecting.
Yeah, I think even I'm seeing that.
Yeah, same here for me.
Yeah.
Something going on with Databricks.
Some network error. So now we will see how different stages are formed in our trained model using our decision tree classification model. So using all these features, it prepared a decision tree. Like using these features, you have to branch into 2 categories. Again, based on this feature, you have to branch into further 2 categories, etc. Okay. This is the decision tree model that it has created using our trained data. And it has formed this model, and using this model, it will predict the final label on our test data if we use this model now, right? Is this clear to everyone? We have formed the decision tree classification model here using our trained data. Okay, please try to refresh your Databricks cloud or log off and log in again. Try to refresh it once. Maybe restart your cluster and rerun it once again. Is it working now?
Yeah, yes.
Okay. So based on the features that we have sent as input, like the pixel values, which has the width and height of the pixels as defined here or as explained by Hari, we are trying to determine the final output layer using this decision tree, which we have trained with the training data of more than 50K images. We have trained some 50K images to this decision tree, using which it formed its own decision tree with the given set of input features and output values. And using this decision tree model, now what we are going to do, we are going to predict our next 10% data's label, which can be an output of 0 to 9. We are trying to read the images of handwritten digits, right? And we have 10 label output values, which is our multi-classification. Like we have multiple output labels, which are 0 to 9. And we are going to predict that label output using this decision tree model, right? We have already trained the decision tree using some 50K images. Now we are going to predict the remaining 6K images for its appropriate digits. Okay. Now we want to see what are the distinct classifications or distinct output values for our label. So as we already know, we have maximum 10 digits, 0 to 9. So our output should be from 0 to 9. These are all the distinct values. How much test data we have? We have around 6K test data, 53K training data and 6K plus test data, right? So out of 6K, the prediction should come, should fall under these classifications, which are 0 to 9. Okay. Now, using that model, which we have already prepared, we are transforming our test data and predicting the label, right? We already have a label in our test data, which is the actual value, and we have a set of features, which are the pixel width and height that we captured for that handwritten image. As the data is vast, we indexed all these features and we have some prediction out of this model for each of these images under prediction column. This label is a double, which is an actual value, and this prediction is the output that our algorithm or that our model predicted this image should be based on the pixel values that we have sent as input to the prediction. Okay. So we want to see what are the distinct predicted values out of these images. So what it predicted is again from 0 to 9. But whether it predicted all 6K records as exact digits or not is what we are going to check now. How we will check that? We will check it using our multi-class classification evaluator. We have to define this parameter grid builder for this classification evaluator. Okay. Using this evaluator, we pass the label and prediction, and we will obtain the accuracy of the evaluator. Okay. We are processing almost 6K records, means 6K test data, and each test data is having multiple pixel images, which needs to be passed through all these decision tree branches and come to a final output label, right? So this is a like huge data set which we are going to process, that you can clearly see here when you are evaluating the accuracy. So now using this cross validator model or this multi-classification evaluator, okay, this is the evaluator we have used, and this evaluator will be used under our cross validation library to calculate the accuracy of our output or prediction. Okay, so the metric that we are going to derive from this cross validation is the accuracy by comparing the label column and the prediction column using this multi-class classification evaluator. We are evaluating the result here by comparing the label and prediction. Label is the actual column and prediction is the output that our model or our algorithm has predicted based on the given pixel width and height, right? So by comparing this, we are going to derive our accuracy of our image, like our prediction, right? So by passing this evaluator to our cross validator pipeline, we are estimating or we are calculating our algorithm's accuracy. This is all a definition. Okay, we are not running anything here. We are just preparing the cross validator using our evaluator. Now we are going to use this evaluator on our test data where we have our actual predictions and evaluate the accuracy, right? This is going to take some time because all our 6K records with all its pixels values, it should go into this decision tree and finally come out with a single output label for each of the image which falls under 0 to 9, right? If you try to run this evaluation, it will divide that job into different stages here, because it's a huge data that you are going to process through each of those branches of your decision tree.
in the data preparation cell, where is the DF1 coming from? I'm having trouble running that
Sorry.
cell.
I'm sorry. 1 second. Just use the raw data here, okay?
Oh.
Hema, in that val param grid, what is the add grid, Hema?
One second.
Yeah, here.
This one, right?
Yeah.
Param grid builder. This is the parameter grid used in search-based model selection, where we are defining the maximum depth. Add grid of dating. Array of 4, 5, 6. One second. It has a build of array, builds and returns all the combinations of parameters specified by the parameter grid. Okay. And we are passing this parameter grid to our estimator param maps. Cross validate. These parameters are a list of advanced hyperparameters, hyperparameter keys in this algorithm. Users can set and get parameter values through setters and getters. Maybe this we will check with Srini, like what will be the ideal value for this maximum depth of the graph for these decision trees, like how he came up with these values. But these are the like k values, like hyperparameters or constant values, which are used to tune our algorithms to optimize the performance. Okay.
Okay.
So I think this is only like to come up with same results for each one of us. We can try with different depths and run and see like how the evaluator works. And
I need a small help. My cluster is not starting up. How do I do that?
Your cluster is not starting.
It's saying terminated. That confirm when I go to my cluster,
okay.
It's saying that's not.
This button is not there. Is it terminated?
Confirm button is not enabled.
Confirm. Where is confirm? Okay. Under my cluster, you are seeing the state as terminated. Is it? Then go to this run button. Start. Is it coming here? Are you able to see this?
Yeah.
Now start this.
Okay.
If your cluster is already running, you will not be able to, you will see a stop symbol here. If it is not running, you will see a start symbol here. You have to start this.
It is saying could not start cluster.
Okay, then delete it and try to create a new cluster. Here you have a plus button, right? Create cluster.
Yeah.
Create a new cluster and start it, and then attach it to your notebook.
Okay. Thanks.
Okay. So any questions still here? So guys, like there is one small mistake in the code where you will not be able to run it because there is some old value copy paste error here. Under your feature indexer.fit, you have to use the above data, which is our raw data. Okay, it's not df1, it's raw data here. Okay, are you guys able to run this code till the evaluator?
In my code, I don't have the code for the tree where your tree was displayed.
You are not able to display this tree?
Yeah, because I don't think I have it in the second file. Oh no, actually, sorry, I missed. It is there. Yeah, I can see it.
Okay. Okay, guys, you can run it and see. You can play it play around with it with different hyperparameters and different test data set. Okay, different splits, 80, 20, 75, 25, and see how you can improve this accuracy in the prediction. Okay, I think Srini will take it further tomorrow.
Hema, can you do a quick summary, please? Starting with the file, like what data is there in the file? So I understand the label and the features, but what exactly this data corresponds to?
This data, I think already our friend Hari explained, right? Like this is the data of pixels of a handwritten numeric digit. Okay.
So this whole data is for like one digit?
Yeah, this whole data is the pixel width and height of a handwritten numeric digit with the RGB color code.
Okay, so this one row, like the one that's you've highlighted, not one row, the one section, that corresponds to one digit.
One digit,
not the entire file, right?
Not the entire file.
Okay, so this one is one digit.
So this entire row corresponds to a handwritten digit of 5. The first character is the label. Okay.
So if I have to put it in a easily understandable way, I would say, see, for example, you have say 100 files or 100 images. Okay?
Yes.
So from 0 to 5, you have to classify them based on the the darkness. So from light to dark. So 0 is the lightest and 5 is the darkest. Okay. So here, based on the picture.
What is the? Can you come again about your last sentence?
No, what I'm saying is based on the pixel size is what we are classifying here.
Right.
From the lightest to the darkest. So if we are saying the lightest from 0 to 10, the lightest is 0 and darkest is 10.
No, not like that, right? It's based on the color code, which is darkest in the flow of writing a 0, right? If you write a 0 like this, okay, if your pixel image is brighter at these coordinates, at these positions of an image of 0, then you will predict it as a 0, right?
Okay. You're saying like that, okay. My understanding was it is purely based on the data, because it is showing only two coordinates, x and y. So
Like
there,
this. Okay. If it falls under the image of 0, like this, if you can find more darker pixels, then you will classify it as a 0, right?
Right.
If most of the pixels are darker in this format, then you will classify it as a 1, right? So you will deduct an image out of these pixels with the darker cells and predict that image into a numeric digit from 0 to 9.
Yeah, but what is that data that you're showing in, there you're showing like, one data is like, only, there are only two parameters there.
Hari,
in your, yeah.
Can you please explain once again, like how this pixel data?
No, what I was saying was, my understanding was, you are showing the data in having only two parameters.
Right.
Right. So there, for example, if you take the first one, like 153 to 3 or 154 to 18. So, to my understanding, it was the width and height of the image, which will fall under the first category, category 1 or category 5 in this example.
Think that there is a pixel image of maximum value is some 700, okay, 700 to 700 by 700 pixel.
Okay. Yeah. So that would be the width and height, if I am not mistaken.
Okay.
Oh,
the original black and white images from NIST were normalized to fit a 20 by 20 here. We are using a 700 by 700 pixel box. Okay.
Okay.
The resulting images contain gray levels as a result of, okay. So we are figuring out the more gray pixels and forming an image out of it. One second. Creating pixel data.
Yeah, the other, yeah. See, you can see the red, blue, green, which is, I was mentioning about RGB. So that kind of here you see 1, 480, 480. Can you come down?
This I have to check, Hari, like on how this data is being written. I will check it and explain you in tomorrow's class. Okay.
No problem. To my understanding, it was like the classification is done. based on this whether it's light or dark. Because if you see, if you take the code but which you run, can you go to the code which you run?
Okay. Yeah.
No, the code which you ran in the There you can see. There there are. I can scroll a little bit up. Yeah. See, if you can see here, you can see something like 15315. What is that feature? Features.
Yeah.
But that is getting cut off. I don't know why. For what matter? Why it's getting cut off there? That features is showing dot, right?
Okay. This is a 780 pixel maybe. Okay. Where we have this 5 is 153, 154. This is X coordinate. Okay.
No. I'm asking why the features is getting cut off. Can you be able to
display this? Is it what you are doing?
Yeah.
Yeah, we can, there are like space limitations here, right? If it has like more than 200 values, so it is displaying like this is the data, this is the sample. First few columns it is displaying, remaining will follow, right?
Because each of these
I will try to show
one column. No, you're saying show 10 something. Yeah, show one.
We'll see if it can display this. No, this is also cut off. Oh, okay. Somewhere we are printing the features, right? Training, count, test images. Oh, here also it is cut off. How do we display the complete features?
You have the labels. Do you have the labels?
Data dot features. This is a DF, right? Sure. I think we have to select it, right? We will select.
No, you have to give the training data or test data there. No? You're just mentioning raw data. So maybe you have to mention this.
Raw data is the complete data, right? We didn't split it here yet.
No, here, if you say show.
Oh, there you want to give? But I think this is returning as only the limited data. This show is a no, it's limiting actually. I can't see the complete data here. Okay, we'll see. We'll check how we can print the entire data here on how it is creating the features. Okay.
Yeah,
we'll explore and figure out. Yeah.
Yeah. Okay. No problem.
Okay. Thank you all. If you have any questions, like please let me know. Otherwise, we'll close the session.
I'm good.
Thanks, Emma.
Okay.
Thank you. Thank you.
Thank you.
Thank you all.
Thanks, Emma.